Hi friends, welcome to all. In this video, we are going to solve ENSA final packet tracer skill assessment. Friends, before coming to this activity, if you wish to get any technical support, you can contact our team. All the details given in the description below. And also, if you wish to get these type of technical videos, consider subscribing. Here we can see we are in a physical mode, and here they given the topology R1, R2, and we have 4 switches S1, S2, S3 and S4 and 4 NG devices including this server DNS web server, and here they given the addressing table. Okay, we need to connect these devices here according to this topology. We will go through the instructions. Here they given the instructions when you do it online, and we will complete all tasks in packet tracer physical mode. Okay, we are already in physical mode. So we'll go to the instructions. Part 1, place devices in proper locations and connect them with proper cables. Place devices in proper locations inside the main wiring closet. So here we can see that our main wiring closet, right? So in the physical mode, place network devices in the following locations. Okay, organize the rack for ease of configuration. Place R1, R2, S1, S2, S3 and S4 from top down with some spaces between the devices. We can do that very easily. Drag two 4331 routers, that is R1 and R2, from the shelf to the rack. Okay, so here we can see that R1 and R2 here at the top. So we must drag these two routers to this rack. Okay, we can drag this R1 from there to this rack, and here is R2. So we need to put some space in between these devices. If you need more spaces, you can do that too. Okay, drag 4 switches S1, S2, S3 and S4 from the shelf to the rack. Okay, here we can see S1, here we can see S2, S3 and here we have S4. So we will drag one by one. Here we have S1. Okay, now we have S2 and S3. This is S3. Okay, and here we have S2. And here we have S4. And here you can see S0 also. Don't drag this S0. We have the same name S1, S2, S3 and S4. So make sure that you drag the same switches to this rack. So now we can see we have R1, R2, S1, S2, S3 and S4. Next is move PCC to table 1 on the left and place it in the left hand area of the tabletop. So it's on table 1. Here we can see table 1 and we need to move PCC. So here we can see PCC. So we have to drag and keep it on table 1. Then move the DNS server to table 1 on the left. So here we can see that DNS server here. Okay. Then place it in the right hand area of the tabletop. Okay, so we need to move this server here because it's a Meraki server. So now we are going to choose this DNS server, drag it and keep it here in this table 1. Then we need to move PC-A and PC-B. Here we can see move PC-A to table 2 on the right and place it in the left hand area of the tabletop, that is on table 2. Then PCB also need to move from left side to the table 2, right side of the table 2. Okay, here we can see that PC-A and PC-B. So we will move that. So we need to move to this table 2. Okay, so how we can move it? So just I will keep this PC here. Okay, so that very easily we can move from here to table 2. So this is PCB and here we have PCA. Okay, just will keep PCA here, okay, PCB here, because they specified we need to keep PCA at the left hand area and the PCB at the right hand area. Coming to step 2, make sure all devices are powered on, okay, power on all devices. So we will check all the NG devices first. So here we can see that button here, okay, let me put on that, and on server put on that, then PC-A and PC-B. Okay, now coming to router, just right click on this router and we'll give inspect rear, and here we can see that power button. We'll put it on. Also on R2 inspect rear, we'll put it on, and the switches are already on because we cannot see any power button here. We can verify that. Inspect front or rear. Okay, no power button. By default, it's on. Okay. Now we will go to step 3. Connect devices according to the network topology. Use the logical topology diagram to connect the devices to the correct ports with the correct cables. Okay, so we need to use our topology here. And first we will connect router R1 and R2, and here we can see the ports G0/0/0 to G0/0/0. We will choose copper straight through here. Then coming to R1, here we can inspect front. Here also we can give inspect front so that we can see this ports little more bigger. Even we can zoom it here if needed. Okay, and if you keep the cursor here, we can see G00 here. Yeah, G000 to R2 G0/0/0. Next, we will connect from R1 to S1 and R1 to S2. So first we will connect from R1 to S1 from G0/0/2 to G0/1. We will choose copper straight through. Then coming to R1, click on inspect front, and we need to choose G0/0/2, and here we can see G0/0/2. Okay, then the other end we should connect to S1. So click on inspect front, and we need to connect on G0/1. Here we can see G0/1. Okay, just to keep the cursor here on this cable so that we can see where this cable is connected. Source device is R1 connected to the port G0/0/2. Then destination device, the other end is connected to S1. Port number is G0/1. So we can verify like this whether we connected correctly or not. Next, we will connect from R1 G0/0/1 to S2. From G0/0/1. Okay, here we can see that just under this G0/0/0. So we need to connect to gigabit Ethernet 0/0/1 to S2. Inspect front G0/1. Okay, we can verify it. R1 G0/0/1 to S2 G0/1. Correct. Next, we will connect from R2 to S3. Choose copper straight through. Coming to R2, inspect front G0/0/2. So here we can see G0/0/2. Connect to S3 G0/1. S3 G0/1. Again, choose copper straight through, and port is G0/0/1 on R2. G0/0/1 here to S4 G0/1. So we can verify it. R2 S4 is correct. R2G002 S3G0/1, correct. Next, we will connect these end devices to switches. Here we can see PC-A is connected to S1, FA0/5. So we will choose copper straight through, and coming to S1, here is S1, we can click on inspect front, and we need to connect to FA0/5. So here we can see FA0/5, fast Ethernet 0/5, PC-A. So here we can see PC-A, fast Ethernet 0. Okay. Again, copper straight through from S2 PC-B. Here is S2, port number 5, PC-B. Okay, we can verify it. Perfect. Also, we can connect DNS and PC-C. Again, copper straight through, go to S3. Here the port is FA0/10. So here is FA0/10 to this DNS or web server, fast Ethernet 0. Again, choose copper straight through. So now we can take cable from here, S4, FA0/10, PC-C. We connected all the devices. We'll go through the next instructions. Part 2, configure basic devices settings. All configurations are made through a direct console connection. So here we have a console cable, and we will connect a device to any end device, and we will configure these intermediary devices. Step 1, configure PCs with IPv4 addresses. Use the addressing table to manually configure the PCs with the full IP addressing. Okay. Coming to addressing table, here we can see PC-A, PC-B, PC-C, and our DNS server. We will configure the IP address as per this addressing table. Here they mentioned only PCs. I think this DNS server may be already configured. Just we will click on this and we will check it. Okay, lock IP settings is logged by authors designed for this activity. Oh, that means already this DNS server is configured. So we need to configure only PC-A, PC-B, and PC-C. So first we will go to PC-A. Coming to IP configuration and PC-A, just I will copy this address. Okay, and here they given /29. So that means 255.255.255. It's 248. They given the default gateway also 64.100.1.1. We will set that to. So it's 1.1. And the DNS server. So here we have the DNS address. We can copy it or we can type it. Okay, perfect. Now we will go to PC-B IP configuration. Here is the IP address and given the default gateway also /24. It's correct. Default gateway is 1.1. Also, we can set the DNS server address. Then coming to PC-C IP configuration, IPv4 address is here. Then prefix /24. So here we must change to 255.255.255.0. Okay, and the default gateway it's at 2.1. DNS server. So we configured all the 3 PCs, PC-A, PC-B and PC-C. Make sure that you set IP address, subnet to mask, default gateway and the DNS server. Now coming to step 2, configure router R1 and R2. Okay, configure R1 and R2 with the following. Okay, we have 7 configurations. Prevent the router from attempting to resolve incorrectly entered commands as domain names, router name, then encrypted privileged exit secret password Cisco ENPASS, then console password, then set the minimum password length, encrypt all clear text passwords, then configure appropriate banner MOTD, message of the day. So to configure these devices, intermediate devices, we cannot access directly here. We can see this configure is logged by others design. So we can choose here this console cable and we can connect to any NT devices. Okay, coming to R1, we will inspect rear and here we can see console, connect to console port. The other end we will connect to PC-A. Okay, so here we have this RS-232. Also, we'll connect R2 because we need to configure R1 and R2 right now. Inspect rear, we'll connect to console, then PC-B RS-232. First of all, we will configure R1. We already connected console to PC-A. Click on PC-A, we will go to terminal and click OK. Would you like to enter the initial configuration dialog? No. Enable configure terminal. First one is prevent the router from attempting to resolve incorrectly entered commands as domain names. So we need to give no IP domain lookup. Okay. Next is a router name. Okay. We will set the host name as R1. Then we need to set encrypted privileged exit secret password. Okay. We will enable secret Cisco ENPASS. Now we'll go to line console 0 and set the password Cisco CONPASS and give login command. The next, set the minimum password length to 10 characters. So we have the command security passwords min length 10. Then we need to encrypt the clear text passwords using service password dash encryption. Also, we need to set the banner MOTD. So they did not specify any specific banner. So we will set our own banner. For example, warning, authorized users only. Okay. Just we'll exit and we'll save it. Copy, run space, start. Same way, we need to configure on R2, which is connected to PC-B. We already connected console to PC-B. So we'll click on PC-B, go to terminal, leave as default and click OK. We'll give no. Enable configure terminal, no IP domain lookup. We'll set the host name as R2. Then enable secret Cisco ENPASS. Then we'll go to line console 0. Set the password as specified Cisco CONPASS. Login. Then we will set the minimum length security passwords min length 10. Also will encrypt all plain text passwords using service password dash encryption. Also we will set the banner MOTD authorized users only. Exit and we will copy run space start. Coming to B, configure the interfaces of routers R1 and R2 as follows. Configure interface G0/0/0 with a description and IPv4 addressing. Also, we need to configure G0/0/1 and G0/0/2 with the description and IPv4 addressing. All interfaces should be ready to send and receive traffic. That means we must activate all these interfaces. So now we will configure this on R1 and R2. First of all, we will do it on R1. In the addressing table, we can see the IP address of each interfaces on R1. So we will go to R1. Okay, password Cisco CONPASS. Enable password Cisco ENPASS. So first of all, we will go to interface G0/0/0. We will set the description. This is connected to R2. So we will give the description connected to R2. Then we will set the IP address G000. Here we can see the IP address. Just I will copy it, or you can type it correctly. 198.51.100.1. Then prefix the given /30. That means 255.255. Sorry, I need to give IP address. We'll paste. Then to mask 255.255.255.252. Then we must activate this interface G0/0/0 using no shutdown command. We will go to next interface G0/0/1. Interface G0/0/1. We'll give the description. And here we can see this G0/0/1 is connected to S2. So we will give the description as connected to S2. Then we will set the IP address. Just I will copy from here. Then submit to mask. Activate the interface by no shutdown command. Then coming to interface G0/0/2. Description connected to S1. Then set the IP address /29. IP address, then subnet mask is 255.255.255.248. Activate the interface and now shutdown command. Okay, end. Copy run space start. Next we will do it on R2, and we already connected to PC-B. Console password Cisco CONPASS. Enable password is Cisco ENPASS. So first of all, we will configure G000. Here we can see R2 G0/0/0. Interface G0/0/0, which is connected to R1, right? So we will give the description connected to R1. You will set the IP address. Just I will copy from here. Then /30 subnet to mask is 255.255.255.252. Activate the interface, now shut down. Then we can go to the next interface G0/0/1, which is connected to S4. We'll set the description. Connected to S4. We will set the IP address as per the addressing table. Then submit to mask. Activate this interface. Now shut down. Then we will go to interface G0/0/2. We will set the description. We can see this interface is connected to S3. So we can say connected to S3. We will set the IP address as per the addressing table. Here we can see that. Let me copy it. Then given prefix /27, that means 255.225.224. Okay. Activate the interface. Now shut down. End. Copy run space start. You can verify all the configurations be done and make sure that done it correctly. So we can use the show IP interface brief command, and here we can see all the interfaces with IP address, status and protocol. Okay. Next, coming to C, configure SSH. Domain name CCNA-lab.com, then create an administrative user in the local database. Username should be admin, and we must create a secret password for this username, admin1pass. Then set login on VTY lens to use the local database. Then we must accept only SSH, not telnet. Then use an RSA crypto key with a 1024 bits modulus, and we must enable SSH version 2. Okay, we will do it on R1 and R2. First of all, we will go to R1. We will set the domain name, IP domain name, the given CCNA-lab.com. Then we need to create the username and password. Username admin, secret password admin1-pass. Then set login on VTY lines to use the local database. So we need to go to line VTY 0215, login local, and they mentioned to accept only SSH. So transport input SSH. Then we need to use RSA crypto key with the 1024 modulus bits. Crypto key generate RSA. Bits in the modulus, so 1024. Press enter and give IP SSH version 2. Okay. So now we will do it on R2. We will set the domain name, IP domain name, CCNA-lab.com, username, admin secret password admin1pass. Okay, now we will go to line VTY 0215. We will set login local and we will transport only input SSH. Exit and crypto key generate RSA. modulus 1024. Press enter and give IP SSH version 2. Next, we will go to step 3, configure switches S1, S2, S3 and S4. Configure the host name according to the addressing table, then configure management interface, that is SVI for VLAN 1, set the IPv4 address and activate the interface. So, here we can see they given the IP address for these switches. Then configure default gateway. Okay, we will do it one by one. We will take this console cable. First of all, we will go to S1, inspect rare, and here we can see console. Will connect to PC-C. Okay. Now we'll click on this PC-C. Go to terminal. Okay. Enable configure terminal. We will go to interface VLAN 1. Then we will set the IP address. For this S1 VLAN 1, here we can see the IP address. Prefix is /29. 255.255.255.248. Activate it. Then we need to set the IP default gateway. We can give here itself, we can give the command here itself, or we can exit and we can give the command. We need to set the default gateway in the global configuration mode. Default gateway. It's a 64.100.1.1. Okay. Next, we will configure S2. We can reconnect this same cable, same console cable, which is connected to PC-C. So, here we need to give inspect rare, and on S2 also we will give inspect rare. So, we can drag this console cable to S2. Okay, now we are in S2. Right, again we will go to PC-C, we will close this, go to terminal again, click OK. Before that, let me verify I set the host name for S1. I will verify that. Okay. Oh, we did not set the host name. So, we will set the host name also here, S1. Okay, now it's easy to understand the switch. Now, let me reconnect to S2. Just drag and drop here in this console. Now, we will do it on S2. Enable configure terminal. We will set the host name as S2. Interface VLAN 1. IP address. Just I will copy from here, addressing table. Then subnet to mask. Activate this VLAN 1 SVI. Default gateway. So, 192.168.1.1. Now, we will do it on S3. We will reconnect to S3. Drag from S2 to S3. First, we will set the host name. S3. We will go to interface VLAN 1 and set the IP address, S3 IP address here, /27. So it's a 224. No shutdown. We will set the IP default gateway. It's 129. Then coming to S4, enable. We will set the host name S4, interface VLAN 1, IP address for S4 with the subnet to mask. No shutdown. Default gateway 2.1. Next, we will go to part 3, configure single area OSPF v2. Step 1, configure single area OSPF routing. Configure the OSPF routing process, and we must use process ID 1. Manually configure the router ID, use 0.0.0.1 for R1 and 0.0.0.2 for R2. Configure network statements for the appropriate networks on R1 and R2. Okay. For the purpose of this assessment, enter your network statements in the following order. Okay, we must follow this order when we enter the network command. Okay, we can do that. First of all, we will do it on R1. R1 is connected to PC-A. Okay. Password Cisco CONPASS. Enable. Password is Cisco ENPASS. So router OSPF process ID should be 1. Then they specify to give the router ID as 0.0.0.1. Then network we must give in the specified order G0/0/2 first, then G0/0/0. So let me give a show command here, do show IP root connected. So it will be easy to identify the directly connected networks. We can give a network. First one they specified G0/0/2. So here we can see that 64.100. Let me copy that. Then /29, that means 0.0.0.7 area 0. Also network, next one is G000. Here we can see G000. Let me copy that network address. Then /30 wildcard mask 0.0.0.3 area 0. Next we will go to R2. Cisco CONPASS. Enable Cisco ENPASS. Router OSPF 1. We must set the router ID 0.0.0.2. Then I will give that show command here, do show IP root connected. First we need to configure this network statement G0/0/2. Let me copy that IP address here. Network network address, then wildcard mask /27, that means 0.0.0.31 area 0. Then the second network G0/0/0, here we can see that /30 0.0.0.3 area 0. We will go to step 2, adjust OSPF operation. Okay, configure the appropriate interfaces to not forward OSPF updates where they are not required. So we must configure the passive interface. Then configure the reference bandwidth, adjust the reference bandwidth to 1 gigabit. Okay, that means we must set the auto cost reference bandwidth to 1000. Then configure the OSPF network as a point-to-point network. Okay, that can be done using the command. Then configure the hello time for 30 seconds. Okay, we will do that one by one. First of all, we will do it on router R1. We'll configure the passive interfaces, right? We already in this router modes, we will give a passive interface G0/0/1. We can see these interfaces G0/0/1 and G0/0/2 are passive interface. Again, passive interface G0/0/2. Then we will set the auto cost reference bandwidth 1000. Okay. Then we need to set this point-to-point network. So we need to go to the interface G0/0/0, which is connected to R2. We will give IP OSPF network point to point. And finally, we must set the hello time to 30 seconds. IP OSPF hello interval 30. Next, we will do it on R2. Passive interface G0/0/1 and G0/0/2. Passive interface G0/0/2. Then auto cost reference bandwidth. Actually, in this activity, I am not using any shortcuts. I am typing the entire command because some of them may be confused if I use many shortcuts. So instead, I am just typing the entire command. We will give auto cost reference bandwidth 1000. Then we will go to interface G0/0/0 IP OSPF network point-to-point. Then we will set the IP OSPF hello interval 30. Now we will go to part 4, configure access control and NAT. So step 1, verify connectivity. PC-B cannot visit the web server. Then PC-C cannot ping PC-A. We will go to PC-B and we will go to web browser. And here we can see this web server. www.ensa.pka, and we are waiting for the page. So it's not coming. Parallelly, we will ping PC-C cannot ping PC-A. So we will get the IP address of PC-A. So we'll go to PC-C. Request timed out. It's correct. Step 2, configure NAT. Configure static NAT on router R1 with a public IP address 64.100.1.7 to allow PC-B to access the web server. Okay, we need to do that. So we must configure on R1. IP NAT inside source static. So it's a PC-B. We must get the IP address of a PC-B. Here we can see the IP address of PC-B. Just I will copy it. Okay. 192.168.1.5, and with the public IP address given here. Okay. Now we will specify interface G0/0/0 as IP NAT outside and interface G0/0/1 as IP NAT inside. Next, we can see configure PAT on router R2 to enable some devices on the network attached to the G0/0/1 interface to access the internet. So create a NAT pool named IP NAT1. Okay, we need to create the pool with IP address range of 209.165.202.140 up to 150 with the subnet mask of 255.255.255.224. Oh, that means we need to create this pool, right? Then create a numbered ACL, ACL1 to allow devices with IP addresses range 172.16.2.1 up to 2.15 to access the internet through NAT. Then use PAT to allow the range of the public IP address to be shared. Okay, that can be done. So we need to go to R2. First of all, we need to create that pool. So IP NAT pool, they given the name here, IP NAT1. You can type it or copy, and the pool address range they given here. Let me copy that. Okay, 209.165.2. Okay, here we have, we need to put only space. Okay, up to 150. Now we need to give the net mask. They specified here. Let me copy that too. Okay. So everything correct. Press enter. Now we need to create this ACL. IP, sorry, say numbered ACL. So we'll give only access list 1 and permit address 172.16.2.1 up to 15. So let me give the network address. (2.0). Then we need to give the wildcard mask 0.0.0.0.15. Okay, now we will go to interface G0/0/1 and we will give IP NAT inside. And also we can give interface G0/0/0 IP NAT outside. Okay, use PAT to allow the range of the public IP address to be shared. Oh, actually we need to configure this IP NAT inside source list. We created access list to 1 with the pool IP NAT 1, IP NAT 1 overload. Next, we will go to step 3, configure access control on R1. Create a standard ACL, it's a standard named ACL to allow only PC-B access to the R1 VTY lines. Okay, apply the ACL. So we can do it on R1. We need to give IP access list standard. Let me copy that name. R1 dash VTY dash limit. Now we will permit only PC-B. So we should get the IP address of PC-B. Permit this host, then IP address 192.168.1.5. Now we need to go to line VTY 0 to 15, then access class. Our ACL name is here, in. Then on S1, create a standard ACL S1 dash VTY dash limit to allow only PC-B access to the S1 VTY lines. Then apply the ACL. We will do that. So we can see currently we connected to S4. Okay, we will connect to S1. Okay. Enable configure terminal. So we will give IP access list standard. Let me copy that name. Okay, then permit host 192.168.1.5. Then line VTY 0 to 15, access class or access list name, in. Next, we will go to step 5, configure access control on R2. Create a standard ACL R2-VTY-limit to allow only PCC access to the R2 VTY lines. Okay, this is on R2. Also, we need to create these access list. Okay, first of all, we will create this R2-VTY-limit standard ACL. So we need to go to R2. Okay. IP access list standard. Let me copy that name. And permit only host PC-C 172.16.2.5. Line VTY 0 to 15, access class, better I will copy that name, ACL name here, R2-VTY-limit in. Okay. Next, create an extended ACL named R2-security to restrict access from the internet. So, we must allow FTP connections from the PC-B public IP address to the web or DNS server. Okay, we will do that one by one. First of all, we will create that named extended ACL IP access list extended. Let me copy the name. It's on R2. Okay. Now we must permit FTP. Okay. So we need to give a permit TCP only from the PC-B public IP address that already we configured here 64.100.1.7. So this is the public static NAT to be configured. Okay. To the web or DNS server. So we should get the IP address of our DNS server. Okay. Oh, it's incomplete command because we need to specify the protocol TCP, right, equals FTP protocol, FTP, right, perfect. Okay, here I got some error, let me check it. Permit TCP host, we given the IP address. Oh, here we specified the IP address, so we must give a host command. Okay, correct. So here after this IP address, I need to specify host because we are allowing from web or DNS server. Okay, host, then IP address, then EQ equal FTP. Perfect. Then deny all other FTP connections from the internet to the R2 LANs. Okay, we can give a deny TCP any equal FTP, right. Then deny all SSH connections from the internet. Okay, we must deny TCP any equal SSH. So the port number is 22. Then allow all other types of connections from the internet. So we must permit IP any. Now we must apply this. Your ACL should consist of 4 statements that correspond to the 4 requirements above. Yes, we already done that. Here we done 1, 2, 3, 4. Okay. Now apply the ACL. So we must apply to the interface G0/0/0 IP access group. Our ACL name is here. Let me copy that. IP access group, then name inbound in. Now we will go to step 6, configure access control on S3. Okay. So we need to reconnect from S1 to S3. Okay, now we are on S3. Create a standard ACL S3-VTY-limit to only allow PC-C access to the S3 VTY lines. Okay. So here we will create the IP access list standard. Let me copy that name. and we will permit PC-C. Now we will go to line BTY 0 to 15 and access class. Let me get this name in. Okay. Next we are going to part 5, perform configuration backup and iOS update. Step 1, use TFTP server to backup device configurations. Backup the running configurations of R1, S1 and S2 to the TFTP server on PC-B. Okay, we should backup the running configuration of 3 devices, R1, S1 and S2. And the name of the configuration file should be R1 dash run dash config, S1 dash R1 run dash config and S2 dash run dash config. Okay, we must specify this particular name, whatever they given here. Okay, we can do that. First of all, we will do it on R1. We'll go to R1. Okay, password Cisco CONPASS. Enable password Cisco ENPASS. Right. Now we are going to copy running config. So I can give run or running config to the TFTP server, right? Yes. Now address or name of the remote host. They specified on PC-B. So the IP address of PC-B is here 192.168.1.5. Then destination file name, that should be r1-run-config. Let me copy it and paste here. Okay, this much bytes copied. Next we will go to S1. S1, we are on S3. So let me reconnect to S1. Okay. Okay, now we are on S1. Let me end copy running config, or we can give short run TFTP. Same IP address, let me type it 192.168.1.5 and name should be like this. Okay, perfect. Next we will do it on S2. Terminal. Okay, S2 enable. We will give a copy run space TFTP 192.168.1.5 name. Let me copy that. Okay, writing. Okay, done, copied. Right, perfect. Now next step, to use TFTP server to update or upgrade iOS software. Obtain a newer iOS image from the TFTP service on the web or a DNS server. The newer version of the switch iOS is C2960 LAN base K9 MZ.150.2AC4.bin. Okay, so we are going to upgrade our iOS from this server. Our iOS file is in this server, right? Then configure S3 to use this newer version iOS after reloading. Okay, so we should go to S3. Let me reconnect from S2 to S3. Reopen terminal. Okay, now we are on S3. Okay, let me end it. We need to boot the no, I mean we need to copy this iOS file from TFTP to the flash. So copy from TFTP, okay, to our flash of S3, correct. Address or name of the remote host. So it is in the DNS web server. So let me copy this IP address. Okay. Then source file name. That file name already given here. I will copy it. Copy and paste here. So name is correct. We are going to press enter. Destination file name anyway not specified, so we will give this a default file name. Just press enter. Okay, now we will wait some time. It's copying, completed. Now we need to configure S3 to use this newer version iOS after reloading. Okay, so here we need to go to global configuration mode, configure terminal, and we need to give a boot system, that new OS file name we can copy from here. Okay, perfect. File name is correct. Then press enter. Exit. Now we need to save it. Copy, run space start. Then we can reload. Confirm. Perfect, reloaded. Okay, here I can see the completion status only 99%. So we will verify the check result. Anyway, when you do it online, you won't get this option maybe. And oh, we given this s1-run-config name incorrectly. Let me verify that here. s1-r1. I expect there is a space. Oh, actually I just copied from here. I expect there may not be any space. So we will verify on S1, right? Okay, just we'll verify that on S1. Let me reconnect to S1. Okay. Terminal. Okay, we will see that last part already we done it. Here we given that S1. Oh, here we can see S1 dash, there is a space. Actually that space should not be there. So make sure that when you copy this name, that space not coming here. Okay, let me repeat that again. Here, copy run tftp. Okay, then address or name of a remote host. Okay, now this let me type it, or I can remove that space. Just I will copy and paste here, then just remove that space here. Okay, so it is copied. Perfect. Yes, now it's 100%. So when you do this activity, make sure that you are not copying from the instructions. Instead of that, you can type it correctly. Okay, perfect. That's all in this video. We configured ENSA, Final Packet Tracer Skill Assessment, successfully. Friends, if you get any doubt or if you wish to get any technical support, you can contact our team. All the details given in the description below. Stay connected. We will meet again with the next video.
Thank you.